Hello everyone, today we will see the stepping motor, unit 2 from your special purpose electrical machine. So in this lecture we will see what is stepping motor or stepper motor, its introduction, its a classification of stepper motor, and then we will see construction and working of variable reluctance stepper motor. Okay, so let us go ahead. So stepper motor is also known as step motor or stepping motor. Stepper motor is a special electrical machine which rotates in angular steps in response to a programmed sequence of input electrical pulses. That means stepper motor rotates in angular direction, okay, along with the steps, okay, and then steps are to be programmed by the user. When any electrical pulse or any excitation is given to that stepper motor in programmed manner, then your stepper motor will run. So stepper motor is basically a brushless stepper motor. Okay. So control and position. So whenever in the automation, if you want to control the position of the motor, or we want to control the speed of the motor, or we want to control the both speed and position of the motor, then stepper motor is the best choice, or you can say a top choice when okay. And also the stepper motor is available at very low cost. The second point is that in the stepper motor there is no feedback loop. Feedback is given to the stepper motor, so it works on the open loop configuration. The application of stepper motor are very large, that is in printer it will be used, it is used in the graph plotter, tape driver, disk drivers, IC fabrication, your wrist watches or electrical watches, or you can say even it goes to the satellite imaging or robotics. Okay, the stepper motor works on the principle that a magnetic interaction takes place between the rotor and the stator, which makes the rotor move. So what is the principle? So principle is that, so whenever there is a magnetic field which is present in the rotor and the stator, then your rotor will move. So magnetic interaction taken place in the rotor and stator. So your stator, when I talked about the stator, so stator has a winding, whereas the rotor does not have any winding. So what is rotor? Rotor is a silent structure. It does not have any winding, and also it may or may not have a permanent magnet. So basically based upon these facts, again the your stepper motor is divided or classified. So your stator, I am repeating, stator has winding and rotor does not have winding. Rotor may or may not have a permanent magnet. So stepper motor is usually chosen because of its robustness and reliability. When you go in the market, and you will find that the power ranges for this stepper motor is from 1 watt and to the 2.5 kilowatt. So it's large variety in the power ranges. Also when you go for the torque ranges, so torque ranges goes from 1 micro newton meter to 40 newton meter. Okay, so these are the different ranges when you want to buy the stepper motor. So next point is stepper motor can be classified into two types. One is called as with permanent magnet. This is type. Okay. And then another one is called as without permanent magnet. Or you can say that it is also called as variable reluctance type. And the third is your hybrid type stepper motor. Then we will see the variable reluctance, or you can say VR stepper motor or a stepper motor without permanent magnet. So again it is based upon the principle, that is when you place any magnetic material in the magnetic field, so it will experience that there is some force which will align this magnetic material to a common path. Okay, and that common path relates to the minimum reluctance. So whenever there is a minimum reluctance is there, so on the basis of that, the magnetic material which is placed in the magnetic field is aligned to a specific path. Okay, so the stator, when I talked about a VR stepper motor, so stator has a silent poles, and which has a concentrating winding on the stator, which forms a different phases, and that phases are called as stator phases. These stator phases are excited by a current pulse which will generate a magnetic field. So I'm repeating it. So stator is having some windings with different phases. Okay, which we will see it again. Okay, and then that stator phases are actuated or excited when we give a current pulse, or you can say activate or driving pulse. Okay, and then that driving pulse establish, or you can say generate a magnetic field. The rotor is also silent in structure, with it has a projected teeth. Okay, it has a projected teeth and it does not have winding, as I already told you that rotor does not have winding or a permanent magnet, because this is VR type of stepper motor, so it does not have a permanent magnet. This is without permanent magnet stepper motor, that is variable reluctance stepper motor. So when we look for the variable reluctance stepper motor, it is again subdivided into two types. One is called as single stack and another one is called as multiple stack. Okay, so before starting this variable reluctance stepper motor, that is single stack stepper motor, we will see what is reluctance. So as you know that reluctance is nothing but the magnetic resistance, which we are calling it as a reluctance, or you can say it is also called as magnetic reluctance. It is a concept which is used to analyzing the magnetic circuit. Okay, so reluctance is defined as a ratio of your magnetomotive force, that is your F, to your magnetic flux. So it is defined as the ratio of magnetomotive force to magnetic flux, where your R is nothing but the reluctance, which is measured in the ampere turn per Weber, and then F is your magnetomotive force and your phi is magnetic flux. Next we will see the single stack VR stepper motor. So in single stack VR stepper motor, the stator is, this is your stator. Okay, so you can see, I will draw it here. Yes, so see, this is this is your rotor tooth. Okay, this is your rotor. First inside the rotor, then this is your shaft is defined. This total is your rotor. Okay, and then this is your stator. So you can see that the small lines are there which defines your stator winding. Okay, and this total is called as stator core. Okay, and this all the teeths, or you can say they are calling as poles. Okay, and you can see this switching circuit. Okay, this is what you can say constructional diagram. This is your switching circuit. So you can see that there are, this is four phase 8 pole single stack virtual reluctance variable reluctance stepper motor. Four phases means this A B C D are four phases are there. Okay, and they are 8 poles. Okay, 8 poles on, you can say that 8 poles on the stator. Okay, 8 poles on the stator. This is A dash, B, B dash, C dash and D dash are the 8 poles on the stator, whereas you can see that this is your rotor. So rotor has poles, 6 number of poles. So 6 poles for rotor and 8 poles for stator. 8 poles for stator. So when you look at this particular diagram in terms of switching circuit, so you can see that the your stator pole, your rotor stator poles A and A dash are connected with the uh, serial connection. Okay, and then we have a switches, that is S1, S2, S3, S4. Okay, so the material, when I talk about the stator material, the stator material is of silicon steel. Okay, it is made up of silicon steel stamping, whereas your rotor is made up of laminated silicon steel. This is also silicon steel, but it is laminated silicon steel. Okay, and when you talk about the poles on the stator, so generally they are in the even numbers. Okay, so even numbers, but you may find that in some of the stepper motor that stator poles are in odd number. Also, you can see that, as I told you, that the stator pole has a winding. So when there are even number of poles, the winding on the opposite poles, okay, see here, the winding that is A and A dash, these are the opposite poles. So the winding on the opposite poles are connected in series. See here, winding on the opposite poles are connected in the series, so that the currents in the winding generates a magnetic flux. Okay, and whenever there is a odd number of poles are there, so the number of phases, when the odd number of poles in the stator are there, so the number of phases and number of poles are equal in that stepper motor. Okay, the magnetic, or you can say the material which is used for stator and rotor, it should have a high permeability. It should have high permeability. It should have high permeability. Okay, so the working of stepper motor, now we will see the working of stepper motor. You can see that there, this is your stator. Yes, this is your stator. Okay, and the stator poles, this is your rotor, and then rotor poles. Okay, and so your this rotor has some teeth. Okay, these are projected outwards, these are the teeth of the rotor, and this stator is also having the teeth. Okay, so number of rotor teeth and stator poles are not equal. Okay, because we can see that here there are 6 teeth in the rotor and there are 8 poles, or you can say 8 poles in the stator. So if they are equal, then they will not produce, you can say, your motor will not be self started. Okay, when there are no equal number of poles, stator poles and rotor teeth, then your motor will be self starting, or you can say that it may have a bidirectional rotation of the rotor. So this figure generally it shows you the 8 pole single stack variable reluctance stepper motor. Okay, so before starting its working, you can see that your stepper motor, that is your rotor, is at any position. So rotor teeth can be at any position before the actuation, or you can say excitation. So initial position of the rotor, which we have seen earlier, so this is what your initial position. So you can see that rotor is somewhere in between A and A dash. Okay, so this is what the initial position of your rotor. Fine. So, and when we switch on, and you can see that switch positions. Okay, so these are the switch positions. So S1, S2, S3, and S4 all are open condition, or you can say they are zero. They are zero. When you put, or when you press any switch, so its value will becomes 1. Okay, so S1, S2 in initial condition, your rotor is at any direction and your all the switches are in open condition. Okay, so when you turn on the switch S1, okay, so what is happen when you switch S1 is closed. When you close this switch, this S1 is closed. So what is happen, this A and A dash, so your A and A dash will energize. Okay, so after getting the energy, or you can say excitation, to this phase A phase, okay, this what will make, this will make your stator poles A and A dash as north and south pole. So this you can see in this diagram. Okay, so when your S1 is switched, so this is the nothing but your north and south direction, or magnetic pole. Okay, so the stator poles attract the rotor teeth and it will rotate to get a position with minimum reluctance. So whenever S1 is pressed, your A is energized. Okay, and when A is energized, it will make your stator poles as A and A dash as north to south magnetic pole. Okay, and then your stator pole attract the rotor teeth. It will attract because it is connected with the magnetic field. Okay, and then it will rotate to get a position with minimum reluctance with minimum magnetic resistance. In the next step, when we switch S2 is turned on, then S1 will be off. So in the first case, what we have done S1 is turned on. Okay, this is your S1 is turned on, and then S2 is, all the three switches are off. The second time, okay, so your position of your stepper motor is at 0 degree. The position of a stepper motor at 0 degree when S1 is on. When S1 is on, now S2 is on, and other, that is S3, S4 and S5 are off. Okay, so what happens in that case? So in that case, your uh, your phases, that is your B phase is energized, whereas your A phase is de-energized. So, okay, so what happens when you excite your phase B? Your stator poles, that is B and B dash, get magnetized, and then rotor will move in a direction where it will get a minimum resistance, magnetic resistance, or you can say where it will get a magnetic minimum reluctance, magnetic reluctance. Okay, so it will move in some angular direction, or you can say at angular distance where the minimum reluctance is there, where is the minimum magnetic resistance is there. So what happens? So it will move in this direction, that is towards the counterclockwise direction. Counterclockwise direction, or you can say that is anti-clockwise direction. Okay. How much direction it will move? Its direction depends upon the number of rotor teeth and number of stator phases. Okay. Also, if you want to understand, it will initially moves to the a single step angle. And what is that step angle? So step angle is nothing but the angle through which the rotor moves for a switching operation. This is called as switching operation. This is called as step angle. So how much step angle your rotor will move? It will move the rotor in counterclockwise direction all about a 15 degrees. Why 15 degrees? Because this is the formula for step angle, that is 360 divided by M and R. So what is M? M is nothing but the number of stator phases, and NR is nothing but the rotor teeth. So you can see that in this particular motor we have number of stator phases are 4. This is 4 phase stator motor, stepper motor, and it has number of teeth, that is 6. So your step angle is nothing but 360 divided by 24, that is 15 degree. Fine. So your rotor moves in anti-clockwise direction to the 15 degree. Now the next condition. So see here, I have made a table here. Okay. So in the initial condition, your S1 is on, or you can say your S1 is on. That is your switch 1 is closed. Okay. And all other switches are at 0. That means they are open. So initially step angle will be 0. When the next step, where what we have seen, we have closed the S2. Okay. That is your S2 is on. S2 is on, whereas your others are S1 and S3 and S4 are off. So what we will get in the last PPT, we have seen that we got a 15 degree of step angle. This is what is shown here. Okay, this is what it showed here. So 15 degree. In the next condition, we will make S3 on and rest are off, so you can see that S3 will be 1, and your S1, S2 and your S4 will be 0. So again 15 degree of step angle we will get. So 15 per 15, so your rotor move at 30 degree. When S4 is on, next your S4 is on, okay, that means S1, S2, S3 are 0 and S4 will be 1. Again it will give a step angle of 45 degrees, that is your rotor will rotate in anti-clockwise direction in 45 in 15 degree, so it equals to 45 degree. Next, this will continue to goes on till when we off this machine, or whenever there is last button will on. So for example, in this case, Again I have pressed S1 as on and others are off. Okay, so S2, S3 and S4 are off. So S1 will be on. So again it will goes to the plus 15 degree. So total degree will be 16 degree of angular displacement. Okay, so at that time when we stop it, your stepper motor will also stop and the last position will be of 60 degree. Last position will be of 60 degree. This is what the stepper motor working and its construction. Now the next what we will see is a mode of excitation of stepper motor. So depending upon the how much phases we are energized, your mode of operation is decided. So for example, in the earlier case what we have seen is our stepper motor only one phase is excited at a time. So this is called as one phase mode of excitation. So stepper motor can be operated in different modes depending upon the excitation of stator phases. So when phases are energized at a time, only one at a time, the mode of operation is known as single phase, one phase, or you can say full step on mode, which we have seen that is we got a 15 degree of full step. Okay, so in this mode, your stepper motor gives a maximum of step angle, that is 15 degree, which is maximum of step angle which we have received. So next excitation mode is nothing but two phase on mode. So in this case what happens? So in this case we will on the two phases, that is we can switch on the S1 and S2 and then we will see the operation. Okay, in the first basic step we will have only S1 is closed and other are open, that is S2 and S3 are S4 are open. So in the initial case stage our stator and rotor are inclined to the south and our incline to the 0 degree of step angle. Okay, so in the next step what happens when we open or sorry when we close or when you switch on the S2 and S1. So with S1 is on and S2 is on, this is what the second condition we are saying. So when S1 is on, this is your S1. Okay, and this is S2 is also on, whereas your S3 and S4 are off. Okay, in this condition your rotor tries to move in anti-clockwise direction and then it will occupy some position which is shown here in this figure. So you can see that this is your rotor and which will try to move toward the anti-clockwise direction and it will move somewhere where there is a minimum reluctance. Okay, so it will move to anti-clockwise where there is a minimum reluctance. But what happens when the stator poles A and A dash are magnetized? So there is a repulsive force on the rotor teeth to move it in the clockwise direction. Okay, so there is also a repulsive force because we have excited two phases. Okay, so which will gives your rotor teeth to the clockwise direction. So your rotor moves by 7.5 degree in anti-clockwise direction, which is shown here. Okay, so 7.5 your rotor will move in anti-clockwise direction and take the rest at that position where you will get magnetic force produced by phases A and B are equal, or you can say there is a minimum reluctance. Okay, so whenever there is a magnetic force which is produced by the phase winding, that is your A dash and B dash, because both are in the serially connected, you can see in this image where we have shown. Okay, so here S1 and S2 are close. Okay, so your A and A dash and B dash, these windings will be energized. Okay, and after energizing these windings, okay, so magnetic force is produced, and when both are equal, that is phases of your magnetic field, or you can say a force at phase A and phase B are equal, your rotor will take at rest position and that step angle which we got at this position is your 7.5 degree, which is shown in this truth table. Okay, so when S1 is 1 on S2 is 1. Okay, or you can say S1 is on and S2 is on. Okay, and others are off, you will get a step angle of 7.5. In the next move what we will do, we will make S2 is on and S3 is on. okay, and S1 is off and S2 is off. So at that time we will get again a 15 degree of step angle, which will total angle in this taper motor, which is 22.5 degree. In the next step, okay, in the next step your S3 will be on and your S4 will be on, whereas your S1 and S2 are off. So again we will get a step angle, and which will goes to the 37.5 degree. Similarly, this step will continues. Okay, so this is called as two-phase excitation, or you can say two-phase on mode, where we will excite, or where we will energize two phases of stator. Got this? So next one is our next type of excitation. Okay, there are various other types of excitations also there. One I will again explain it to you. That is 2-1-2-1 phase, or you can say half step mode of operation. All the circuit diagram and your switching diagram is same. Okay, what happens in this? So initial condition, your one switch is on, that is S1 is on, so your stepper motor will be at a stable condition, or you can say a 0 degree. Okay, now remember this 2 is given. So in this step, this is 2, this represents the 2. So 1 1, that is S1 and S2, so your two phases are excited. Two phases are excited, you will get the angle, that is 7.5 degree. Other steps are 0, other S3 and S4 are open. Okay, now next one is your 1, so this one belongs to this. So, and next one will be only one. So S2 will be on, S2 switch will be on, whereas S1 is off, S2, S3 and S4 are off. So this is 2 1, and the next time, only next time two phases are energized. Okay, so two phases means S2 and S3 are energized, whereas your S1 and S1 and S4 will be de-energized. Okay, or you can say they are switches are off condition. So you will get a step angle of 22.5. Okay, next one is only one phase energized. Here in this case S3 switch is on. Okay, and S1, S2 and S4 are open condition or open. Okay, so you will get again a 7.5 degree of step angle. Similarly, this will 2-1-2-1 phase. This is called as 2-1-2-1. That means two the phases are energized, then one phases energized, then two phases are energized, then one phases are energized. This will continues till till your programmer wants. Okay, and the last position where your switches are off, in this case S1 is there. Okay, S1 is closed, or you can say S1 is pressed, or you can say S1 is in on condition, whereas others are off condition. So this is the last step. Okay, and your you will have a total of step, or you can say angular displacement is of 60 degree. Okay, so this is what your variable reluctance taper motor, or you can say a single stack variable reluctance stepper motor. In the next class, we will see a multi-stack variable reluctance stepper motor. Till the time, thank you.